Hello everyone, welcome to the YouTube channel Simply Solve. This is Kushan. This is the fifth video of the tutorial series where we were doing derivations of electrostatics. In this tutorial, we are going to learn electric field due to a uniformly charged ring or a circular loop. Again, if you have any query, do comment in the comment section. Also subscribe to the channel for more videos. So let's begin. So let us consider, look at the diagram. This is a uniformly charged ring having a uniform charge density lambda, right? So this is the charge ring having uniform charge density lambda. So lambda is nothing other than uniform charge density of the ring. Now this O is the center of the ring and P is the point of interest where we are interested to calculate the electric field due to this charged ring. So this distance OP is nothing other than x. So now initially we consider a very small length dl over here. So a very small section of this entire ring dl, let us consider. So for this small section, the charge due to this small section dl is nothing other than dq is equal to lambda dl. Since lambda is the uniform charge density, so lambda is nothing other than charge per unit length. So charge per unit length into this length gives the charge of this small portion dl. Alright. Now first here we will calculate the electric field due to this small portion dl, right? So that can be determined using the basic formula of electrostatics, electric calculation of electric field. So we'll use that formula, but for this small section, right? So dE is equal to 1 by 4 pi epsilon naught. Now Q is nothing other than dQ over here, right? And distance is this distance at point P. So from this dl length to this point P, the distance is r. So by r square, right? Now we'll expand it a bit. So 1 by 4 pi epsilon naught. Now dq is nothing other than lambda into dl, right? Now what is this r? So according to Pythagoras theorem, so this is 90 degree, right? This is 90 degree. According to Pythagoras theorem, see this r is nothing other than x square plus a square under root, right? So I can write r square as, so r square can be written as x square plus a square. So this is the electric field at this point P, right? Now, and the direction is along this direction. So for this point, for this small charge dq due to length dl, the electric field is dE in this direction. Now we will break this electric field into two components. One is the cos component and one the sine component. So let us consider this is the angle theta. So according to concept of geometry, this is a vertically opposite angle. This is also theta, and hence this becomes dE cos theta. So this becomes a cos component, and obviously this becomes the sine component, that is dE sine theta, right? Now for if we consider exactly an opposite point dl over here, right, like this dl over here. Now due to this, the electric field will be in this direction, right, in this direction. Note that the sine component will cancel out this component. So for every small section dl, for every small length dl, the sine components will cancel due to its opposite part, and what is left is only the cos component, right? So the resultant electric field due to any small section in a ring is only its cos component. Sine components gets cancelled out with the opposite component. Thus the resultant electric field at this point can be determined using this formula, integration dE cos theta, right? And this integration is over the whole ring. Integration is over the whole ring. So we can write this electric field as integration 1 by 4 pi epsilon naught. So we are putting the value from the value of dE from the above line, lambda dl by under x square plus a square into cos theta. Now we'll try to calculate what is this value of the cos theta. So we know that cos theta is nothing other than base by hypotenuse, right? So base by hypotenuse. So if this is theta, right, look at the diagram. If this is theta, so the base is x and hypotenuse is r. So becomes x by r, right? And again r can be written as, so x remains as it is x, and r can be written as under root x square plus a square, right? So I can write this as integration 1 by 4 pi epsilon naught lambda into dl, right, divided by x square plus a square into x by under root x square plus a square. Right, perfect. So I'll try to simplify this a bit, not simplify, rather take the things out of the integration which are not required within the integration. So epsilon naught, everything comes out, right? So lambda comes out, this x comes out, only remains is the dl, right? So this portion in the denominator x square plus a square becomes to the power, so see, this is to the power 1, this is to the power half, right? So exponentially it becomes 1 plus half, that is to the power 3 by 2, right? Integration dl, right? Now after we perform the integration, the resultant electric field E, right, turns out to be 1 by 4 pi epsilon naught lambda x by, this part remains as it is, as it was in the previous line, the power 3 by 2 into this dl. So if we integrate it over the entire length, so look at the diagram, entire length, so this is nothing other than the total length of the ring, which is nothing other than 2 pi into a, right? So 2 pi into a. Now, right, so this is a form of that expression, but we can simplify it or write in a more simpler fashion. So what is the total charge in the ring? So we calculated for this small portion dl, right? Look at the first line. For the small portion dl, the charge dq is lambda into dl. So the total charge in the ring, right? So total charge in the ring is nothing other than lambda into 2 pi a, right? So lambda into 2 pi a, which is equal to q. I can write it as q. So simplifying the expression, so E is equal to 1 by 4 pi epsilon naught into lambda into 2 pi a becomes my q, so q into x divided by x square plus a square to the power 3 by 2. So this turns out to be my final formula, right? So I mark this part, right? Now the most important thing is what is the direction, right? So look at this, in the diagram, this direction, I said, like this dE sine theta component cancel out due to the opponent counterpart, right? So what is left is in this direction, in the direction of the cos component, right? So dE cos theta, that this vector dE cos theta gives the direction of the electric field due to this charged ring. So it will be, I can write it like that, along OP, or in a if you try to write in a good way, like you can write or along the axis of the ring, right? You can write along the axis of the ring, because OP is nothing other than axis of the ring. Now let us consider two special cases. So first is case 1, right? So in this case we'll like write where x is equal to 0. Now what does that mean? So in this case we are trying to calculate the electric field at the center of this ring. So the point P, that is the point of interest, now becomes O. So O is now my point of interest. Under the situation, if I put x is equal to 0 in the previous expression, it turns out to be 0. So here in the general expression, so we are putting x is equal to 0, and in the denominator the x is 0, so whatever it is, so answer becomes 0. So electric field at the center of the ring becomes 0. Again, this comes from the intuition, like now let us consider, we are considering in this point. So now this is the point of interest. Now as we are coming down from the point, as the point P closes down to point O, this theta increases, like this theta over here increases, this theta decreases, and this value increases. As it goes on increasing, at point O the theta is 90 degree, so cos theta becomes 90 degrees, so resultant electric field dE cos theta, so at this point also that will be dE cos theta, and dE cos 90 becomes 0. In that way also we can consider from intuition like electric field is 0. And from the general expression format, putting x is equal to 0, we can also find the electric field is 0. Next, case 2, when this x is much greater than a, that means the point of interest is much greater than the radius of the ring. So in that case, electric field becomes 1 by 4 pi epsilon naught, right? Now into x q into x divided by, now if we put this huge value of x over here, so x square becomes a very large value and a square becomes a very less value, right? Hence x square plus a square becomes negligible, and we are left with x square into to the power 3 by 2. These two cancel out with these two, and we are left with 1 by 4 pi epsilon naught, right, qx by x cube. So 1x cancel out, becomes square, hence final answer becomes 1 by 4 pi epsilon naught q by x square, right? Again the direction is along OP, direction is along OP. Okay. So hope this video was informative. Thank you for watching.